Hey, this is the polarization lab that you will be doing for Physics 2213. And I just want to get you familiar with the different optics you're going to be using, because when you look at them at first, they might look the same. So these will all be mounted, of course, in the storage dock on the side of the optics table that you'll just be able to pull them out. But I've taken them out now just for easy access. The first thing that you'll be using is a linear polarizer. And there are two linear polarizers that are identical. So there's a linear polarizer in this mount, and there's a linear polarizer in this mount. And they're the exact same optic inside. This is a fixed linear polarizer, meaning the axis of polarization is fixed and not rotatable. And you'll notice there's a little mark, I'm not sure it'll show up on the video, but there's a little mark right at the 12 o'clock position on this particular one, and that's showing you the axis of polarization, meaning light that's polarized in the up-down direction will pass through this linear polarizer, and light polarized in this direction will get attenuated. Now this one, again, it's a linear polarizer, and you see a little mark that's associated with the axis of polarization. This one is rotatable. So when you rotate the little mark so it's at the 12 o'clock position, it's in the same orientation as the other linear polarizer, and light that makes it through one will then subsequently make it through the other. But of course this one is then adjustable, so it can be crossed compared to the first one or in the same direction as the first one. And so this is a linear polarizer, and you know this one's a linear polarizer partly because you see that same little mark on the optic itself, and partly because it says lin pol on the side. Okay, this one perhaps doesn't say lin pol on the side, but it might get initially confused with a neutral density filter, but the neutral density filters are perhaps more nicely labeled, that they always will say either ND1 or ND3. Okay. So our two linear polarizers are here, the fixed and rotatable. Those get referred to in the lab manual. And then there's the two wave plates, the quarter wave plate and the half wave plate, and they're mounted again in these rotatable stages. This one being a quarter wave plate because it says 1/4 lambda, and so this is our quarter wave plate. And you'll notice it doesn't have a little mark on the optic itself, but it has something. You'll see a little line that goes down through the mount for the optic, and that little line says fast. And remember, a half wave plate and a quarter wave plate have in a direction along which, or a polarization direction along which the index of refraction is greater, and 90 degrees to that, the index of refraction is less. The direction along which the index of refraction is less is called the fast axis, because when the index of refraction is smaller, the wave will travel more quickly through the optic. And so the way it works is, if light is polarized in this direction, it will see a particular index of refraction. If right now I have the fast axis in the up-down direction, and if I had it turned like this at 90 degrees, so the fast axis was horizontal, but I had light coming through this way, it would still travel through, but it would travel through more slowly because it would be experiencing a bigger index of refraction. And of course, these things are operated at a 45, or typically operated at a 45-degree angle with respect to the incoming polarization. And of course, you have to think about why that is. Similarly, in a very similar mount, we have our half wave plates. And again, you can tell it's a half wave plate because it'll say a half lambda on the label on the side. And a similar idea, it has a fast axis which is labeled, and you can rotate this however you need to investigate how a half wave plate works. Okay, so again, these have to get mounted firmly into the table, and when you rotate them, they'll rotate nice and stably. This is kind of a it's a smooth rotation, but it takes a reasonable amount of force to cause a rotation. So once you stop it somewhere, it actually is kind of locked very nicely, and it doesn't sort of move around even if you were to jiggle it. So you can do some really sort of fine adjustments on this when you have to. And of course, you'll be investigating everything that's going on in this experiment with your photodiode, which you used in the first lab. Again, I'm just going to emphasize that for it to work, it has to be turned on. And if you ever see 12 volts on the output on your digital multimeter, that means that you've saturated the detector and you have to somehow reduce the light intensity. Typically for us, that means installing a neutral density filter. Either you'll install it in front of the laser or you can install it directly on this mount. All right, so if this is a neutral density filter, I can install this directly on the light shield if I wanted to. Again, I do this very carefully, very gently. I don't want to cross the threads and end up damaging the threads. Okay, so that, along with the lab manual, should be enough to get you started. I remind you that you will be keeping a lab journal, as always, whenever you do an experiment, and that lab journal gets submitted at the end using the usual Submit My Journal software. All right, good luck.